Okay, we're going to talk about our second method for factoring, and it is difference of two squares. This is probably the easier one of our different methods of factoring. This is purely based around perfect squares. You've been working with perfect squares for a little while, all right? But let's go ahead and jot down the first 12 that you should have memorized. So we know our perfect squares are when a number is multiplied by itself. So 2 times 2 is 4. All right, 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 36, 49, 64, 81, 100, 121, 144. They continue on. All right, this is up to 12 because 12 times 12 gives you 144. So these will continue, but you should memorize up to 144. So your perfect squares is what we are going to be using for a difference of two squares. Just like in GCF, we also need to take into account variables. Okay, not everything in Math 1 has numbers, so we need to also talk about how to take the square root of a variable. So with variables, again, it's going to be pulling those exponent properties. For you to be able to take a square root of a variable, it must have an even exponent. All right, so we know when we just looked at our previous ones, and I'll flip back to it really quick. When we look at this, we've got numbers between 4 and 9, but they are not perfect squares. So not everything with variables are going to be perfect squares either. All right, so again, it has to have an even exponent. So x squared. All right, in order to figure out what your square root of it is you're going to divide the exponent by 2. All right, so my exponent on x squared is 2. So 2 divided by 2 means it would be x times x. All right, which makes sense because if you remember, we said we would add our exponents in order to multiply these, all right, when they have their own base. So 1 plus 1 will bring you back to 2. All right, well, if I did x to the 16th power, all right, 16 divided by 2 is 8. So x to the 8th would be the square root or the perfect square of x to the 16th power. So the last one with GCF had a lot more steps to it. All right, we don't have that many steps when it comes to solving with a difference of squares. So our steps, we always want to start by checking and factoring out a GCF that we learned in the previous section. And then the second part is we're going to factor using square roots. And in the parentheses, I said you need opposite signs. And we're going to talk about that on the first example. So here's our first example. You got x squared minus 25. And one of the things you should understand is when we have a difference of two squares, you're going to have a binomial. That means I have two terms. Okay, we are not going to have trinomials. And the reason is because I have no middle term. If I was to rewrite this to show that it had a middle term, what it actually is x squared plus 0x minus 25. All right, and this pulls in why I wrote in the instructions or the steps that you need to have opposite signs. All right, and the reason we have opposite signs is that's how we are going to cancel out the two middle terms. So let's look at this problem. We've got x squared minus 25. All right, we look to see if we have a GCF, which there is no GCF. So now we look at our square roots. I'm going to take the square root of x squared. So we said take that exponent, divide by 2. 2 divided by 2 is 1. So the square root of x squared is x. All right, now I do the square root of 25, which is 5. So I've taken my square root. So now let's see, how do we write this into an answer? So we know we are going to be getting 2 binomials. Okay, so I go ahead and I have my x and my 5. And as we said, we need it so it cancels out that middle term, and we do that by having opposite signs. So one parenthesis is a plus, one parenthesis is a minus. So when I go and do the process of foiling it, or box method, my answer, all right, should always multiply back to my original problem. So I would end up with x squared first, outer, inner, last. And when we do that, as we can see, these middle terms cancel each other out. One's a positive 5 and one's a negative 5. So my answer, when I multiply it, becomes x squared minus 25, which is exactly what we want it to be. So again, we're focusing on our square roots and making sure we remember to put opposite signs. It doesn't matter if you write the minus first or the plus first. It's multiplication, so it will not change your answer. Let's look at another example. 9x to the 4th minus 36. All right, so one of the things that students get caught with in this, all right, is they go directly to doing square roots. But remember, we always need to check for a GCF first. And this one actually has a GCF. So my GCF between 9 and 36 is going to be 9. I can factor out a 9 from both of these terms in my binomial. So I factor out 9, I am left with x to the 4th. 36 divided by 9 is minus 4. Okay, now what I have in the interior again is a difference of 2 squares. Make sure you do not forget that 9 that we have up front. It needs to continue to stay in there for your final answer. The square root of x to the 4th is x squared. The square root of 4 is 2. We do one with a plus, and one with a minus. And that is our final answer. All right. So as I'm doing them, remember, I didn't post videos for the stuff we did last week because the notes were pretty self-explanatory. But if you want to practice the problems before I do it, always go ahead and press pause. X to the 4th minus 36. We do not have a GCF, so we go ahead and take the square roots of my 2 parts. So we know the square root of x to the 4th is x squared. The square root of 36 is 6. So I go ahead and I got my 2 binomials, one with a plus, one with a minus, and I write the square roots that I just found in. And we're done with that one. All right. So let's look at one where you have 2 variables. All right, so this one is 9d squared minus 49f to the 4th. All right, so we definitely know d and f do not have any part of the GCF because they're different variables. We look at 9 and 49. Again, they do not have a common term. So there's no GCF for this. So we're going to go and take the GCF of everything. So the square root of 9 is 3. The square root of d squared is d. Square root of 49 is 7. And the square root of f to the 4th is f squared. So when we go ahead and write it, as we just said, the square root of 9 was 3d plus 7f squared. And rewrite it but flip that sign in the middle. And we are done. Okay, so with these, it's just knowing your perfect roots or your perfect squares, all right, and always remembering to look for a GCF because sometimes there's going to be problems. For instance, if I was to give you 75x minus 12x to the third, all right, you look at it and go, oh, well, there's no perfect squares. I can't do this one. Not factorable or something like that. But if we look at it, 75 and 12 does have a GCF, all right? I can factor out, why does it keep doing that? I can factor out 3 from each of those. And then x and x to the third, I can factor out an x. So when I factor out 3x from this, it now becomes 25 minus 4x squared, which now we should be able to see that we do in fact have perfect squares. So my final answer would be 3x, square root of 25 is 5, square root of 4 is 2, square root of x squared is x, and we rewrite it and flip that middle sign. Okay, so always check for a GCF and then go ahead and do your perfect squares. All right, I will see you tomorrow.